Section: Introduction. In this section, we discuss the evolution of large language models, LLMs, from basic statistical tools to advanced agents capable of reasoning and engaging in complex conversations. These models can now perform tasks like drafting emails and writing code, but they still struggle with higher-order social cognition, which involves understanding subtle emotional cues and responding with appropriate empathy. Current evaluation methods mainly focus on task performance and fluency, neglecting the relational quality of interactions. We recognize that effective assessment of social cognition requires a counterpart that can simulate human emotions and thoughts during interactions. To address this, we introduce the sentient agent as a judge, SAGE, a new framework that incorporates an LLM-powered sentient agent into the evaluation process. Each sentient agent is defined by 4 factors: its persona, the dialogue context, explicit goals, and hidden intentions. It performs 2 reasoning tasks, one that assesses how the latest interaction affects its emotional state and another that generates a contextually appropriate response. The emotional trajectory produced by the sentient agent provides a continuous measure of how well the evaluated model promotes positive engagement, while its inner thoughts offer clear explanations. By using a variety of personas and goals, SAGE exposes LLMs to realistic social scenarios, from simply listening to providing moral analysis without judgment. Our experiments on 100 supportive dialogue scenarios yield 3 main findings. First, the sentient emotion score aligns closely with established human-centered assessments, confirming its validity. Second, SAGE's rankings differ significantly from traditional evaluation methods, highlighting that social cognition is distinct from general helpfulness. Third, top models like GPT-4o latest achieve high sentient scores without sacrificing efficiency, indicating that advanced social reasoning can be concise. Ultimately, SAGE provides a comprehensive measure of user feelings after interacting with an LLM, which is increasingly important as these systems evolve into companions and decision-making aids. Our contributions include the introduction of SAGE as a fully automated evaluation framework, the creation of a supportive dialogue benchmark, and the establishment of a sentient leaderboard that reveals performance gaps in social cognition. We also make our code and model outputs publicly available to support the development of more empathetic AI systems. In our methodology, we emphasize the importance of user reflections in evaluating interactive agents. We aim to capture genuine user experiences, such as feelings of happiness or connection, which are often overlooked in traditional evaluations. Our sentient agent framework simulates human emotions and cognition to provide a more realistic assessment of agent performance, offering a dynamic environment for evaluation across various scenarios. Section Summary. In this section, we introduce the sentient agent as a judge, SAGE, a novel framework designed to evaluate interactive agents by simulating human emotions and cognition, thereby providing a more realistic assessment of their social reasoning capabilities. Our approach highlights the importance of user emotional responses and offers a structured evaluation environment that captures the nuances of human-like interactions, revealing significant performance gaps in existing models. Section: Sentient Agent: Simulating Human-like Feelings and Cognition. In this section, we describe the sentient agent, which aims to mimic the cognitive and emotional shifts of a real person. To do this, we base the sentient agent on several key principles. We recognize that a person's emotional changes arise from a mix of internal and external influences. Therefore, when estimating emotions, we consider all observable factors while aligning with the person's character and goals. Similarly, a person's actions stem from various influences, with feelings playing a vital role in shaping these actions. We create each sentient agent, denoted as S, by combining 4 essential elements: a persona, a dialogue background, the overall dialogue goal, and hidden intentions. These components together reflect both the conscious and subconscious factors that drive human-like behavior in conversations, including personality, context, objectives, and deeper motivations. Thus, we represent each S as a combination of these factors along with a foundational reasoning engine. We also initialize S with a starting emotional score that indicates its initial emotional state. To simulate emotional changes, the sentient agent engages in multi-step reasoning during interactions. It asks itself a series of questions to interpret the other person's expressions and responses, ensuring it stays true to its persona and context. This reasoning process helps us update the emotional score and understand the sentient agent's emotional thoughts. After simulating emotional changes, the sentient agent determines the most appropriate response based on observable factors and its emotional state. This involves another round of multi-step reasoning, where it considers its emotional thoughts and intentions to decide on the tone and content of its response. We denote this reasoning process as a function that helps us formulate the response that the sentient agent will provide. Finally, we outline the complete interaction process of the sentient agent with other agents. Throughout the dialogue, the sentient agent simulates human-like feelings and cognition, offering valuable feedback through changes in its emotional score and generated responses. After the conversation, we can summarize the feedback from the sentient agent, which includes its final emotional score, providing a clear evaluation of the other agent's performance in the task. Section Summary. In this section, we describe the sentient agent, which simulates human-like emotions and cognition by integrating a persona, dialogue context, goals, and hidden intentions to inform its emotional responses and actions. Through multi-hop reasoning processes, the agent updates its emotional state and generates responses, providing valuable feedback based on its interactions with other agents. Section: Sentient Agent as a Judge, Framing Dynamic Environments for Agent Evaluation. In this section, we describe how we set up dynamic evaluation environments for assessing agents across various tasks. For each evaluation task, we start by initializing a group of sentient agents, which we refer to as a set, with different personas, dialogue backgrounds, and hidden intentions relevant to the task. These sentient agents then interact with the agents we are evaluating, allowing us to conduct a thorough and adaptable assessment of their abilities. To create diverse personas, we use a variety of starting points. We establish 3 types of seed pools. 1. A collection of key descriptive words. 2. A set of sentences that different personas might use in casual conversations. And 3. A range of ages for the personas. When we generate each persona, we randomly select 3 keywords, 3 conversational sentences, and 1 age. We then ask a language model to create a persona profile based on this information, filling in details like the persona's name, age, and gender, as well as their potential job, habits, hobbies, and speaking style. This process ensures that the personas we generate are diverse and relevant to the task at hand. Generating varied dialogue scenes is also important for creating a rich evaluation environment. We define a dialogue scene by 3 main elements. 1. The background event that prompts the conversation. 2. The main goal of the character initiating the conversation. And 3. The character's hidden intentions during the dialogue. Similar to persona generation, we create 2 seed pools for dialogue scenes. 1. Themes for background events, and 2. Hidden intentions for the characters. When generating a dialogue scene, we require the language model to describe the background based on a chosen theme and hidden intention, ensuring it aligns with the character's persona. We also set rules for how the character might emotionally react to different responses during the conversation. Unlike persona generation, dialogue scene generation is closely linked to our evaluation goals, so we adapt our methods based on specific tasks. For our specific task, we focus on evaluating agents in emotional support conversations, where individuals seek support through social interactions rather than professional counseling. We tailor our pool of keywords to include traits relevant to these conversations, such as anger, suspicion, and anxiety. We also define various task-related hidden intentions that encompass both emotional and rational aspects. Additionally, we outline the scene schema by including factors like the event's cause, the sequence of events, conflicts, and other pertinent details. These adjustments help our sentient agent as a judge framework effectively address the emotional support conversation. To evaluate the effectiveness of our approach, we assess 8 representative language models from 4 major families. For each family, we include both a standard model and a reasoning variant for a balanced comparison. The models we evaluate include OpenAI's GPT-4o and its reasoning variant, DeepSeek's models, Claude's hybrid model, and Gemini's cost-efficient model. We also analyze 2 smaller instruction-tuned models to broaden our evaluation. Section Summary. In this section, we frame dynamic evaluation environments for assessing sentient agents by initializing them with diverse personas and dialogue backgrounds tailored to specific tasks, such as emotional support conversations. We generate these personas and dialogue scenes using various seed pools to ensure diversity and relevance, allowing for comprehensive evaluations of agents' capabilities in engaging social interactions. Section: Constructed Supportive Dialogues. In this section, we construct 100 supportive dialogue scenarios across 8 different topics to thoroughly assess the advanced social cognitive skills of various large language models, LLMs. We present detailed statistics for each topic in a table. For our sentient agent, we primarily use DeepSeek v3202-41227, but we also test other models like GPT-4o 20,240,806, Gemini 2.5, and Gemini 2.5 Think. To validate the reasonableness of our framework, SAGE, we explore the connection between user emotions, our main output metric, and the internal thoughts and dialogue of users. This validation shows that the emotional responses generated by the sentient agent are meaningful indicators of the quality of interactions, reflecting deeper cognitive and relational insights. We analyze user thoughts using the Barrett-Leonard Relationship Inventory, BLRI, which assesses the quality of interpersonal relationships in counseling. The BLRI looks at 4 key areas: empathetic understanding, which measures the helper's awareness of the client's emotions; level of regard, which gauges the helper's respect and positive responses; congruence, which assesses the honesty and sincerity of the helper; and unconditionality of regard, which evaluates the consistency of the helper's positive regard regardless of the client's feelings. We prompt DeepSeek v3 to judge how well the sentient agent's internal thoughts align with 12 statements from a shorter version of the BLRI. These responses are rated on a 6-point scale, later adjusted to a 0 to 100 scale. After conducting the evaluation 3 times, we report the average results. Our findings show a clear positive trend. Models with higher emotion scores, like Gemini 2.5 Think and Claude 3.7 Think, also receive better ratings in the BLRI dimensions. In contrast, models with lower emotion scores, such as GPT-4o and OpenAI o1, tend to score lower in these relational aspects. The overall correlation between emotion and thought is strong, supporting our hypothesis that the sentient agent's emotional responses are valid indicators of interaction quality. We also examine how well the dialogue fosters emotional understanding and connection, focusing on 3 perspectives: natural flow, which measures how genuine and spontaneous the interaction feels; attentiveness, which assesses how well the listener tunes into the speaker's messages; and depth of connection, which evaluates the emotional impact of the interaction. We prompt DeepSeek v3 to rate these dimensions on a 6-point scale, later rescaled to a 1 to 5 scale. After 3 evaluations, we find a significant positive correlation between the emotion scores from the sentient agent and the quality of conversation metrics. This supports the idea that emotion is a practical measure of empathetic and coherent dialogue. Models with higher emotion scores, like Gemini 2.5 Think and Claude 3.7 Think, consistently receive high ratings across all 3 dimensions. Conversely, models like GPT-4o and OpenAI o1, with lower emotion scores, also score lower in dialogue fluency and connection building. These results reinforce that the emotion metric is meaningful and reflects genuine patterns of dialogue behavior. The sentient agent's emotional ratings effectively differentiate models capable of producing authentic, empathetic conversations from those that do not. This aligns with SAGE's goal of providing a comprehensive and automatic evaluation framework for socially intelligent interactions. Additionally, the strong correlation with utterance-level assessments indicates that emotion scores capture more than just surface-level emotions. They represent a broader understanding of attentive and emotionally engaging communication. Section Summary. In this section, we constructed 100 supportive dialogue scenarios to evaluate the social cognitive abilities of various LLMs, using DeepSeek v3 as our primary agent. Our findings reveal a strong correlation between the simulated emotional responses of the sentient agent and the quality of interactions, indicating that higher emotion scores correspond to better empathetic understanding and conversational depth among the evaluated models. Section: Robustness of SAGE. In this section, we present the robustness of our SAGE framework by showcasing results from various large language models, LLMs. We evaluated models like DeepSeek v3, GPT-4o, Gemini 2.5, and Gemini 2.5 Think, focusing on their average emotional response scores and the number of tokens generated during conversations. Our analysis highlights the implications of these findings regarding higher-order social cognition capabilities. We observed that while the absolute emotion scores varied, the relative rankings among the sentient agents remained stable. For example, switching from DeepSeek v3 to GPT-4o, Gemini 2.5, or Gemini 2.5 Think increased the mean emotion score significantly, yet the rank order changed minimally. Manual checks indicated that GPT-4o tends to give higher scores for surface-level reassurances, while DeepSeek v3 is more stringent, favoring responses with deeper causal analysis. This consistency in rankings, despite score variability, emphasizes the importance of calibrating evaluations across different sentient agents, a key aspect of our framework. We also found that reasoning capabilities generally enhance emotional intelligence in hybrid models, although this comes with increased computational demands. Models with explicit reasoning, like Gemini 2.5 and Claude 3.7, consistently outperformed their base versions in emotional intelligence. For instance, Claude 3.7 Think scored higher than Claude 3.7, and Gemini 2.5 Think outperformed Gemini 2.5, indicating that reasoning through emotional contexts leads to more empathetic interactions. Additionally, reasoning models generated significantly more tokens, reflecting the complexity of their thought processes. Next, we introduced the Sentient leaderboard, which uses DeepSeek v3 as the judge and compares it with ARENA rankings. We focused on the top 10 models from the ARENA leaderboard that have accessible APIs, excluding those like Grok3. The rankings from our Sentient leaderboard diverged from traditional benchmarks, highlighting SAGE's emphasis on evaluating higher-order social cognitive skills rather than just conversational ability. Notable differences emerged, such as GPT-4o latest ranking second on ARENA but first on the Sentient benchmark, while Claude 3.7 Think ranked lower on ARENA but performed better on our leaderboard. These discrepancies illustrate that SAGE captures essential aspects of performance, like empathy and social reasoning, that general benchmarks may overlook. Our benchmark also revealed a significant performance gap in social cognition between advanced LLMs and older or smaller models. The Sentient scores clearly show performance tiers, with frontier models like GPT-4o latest and Gemini 2.5 Flash Think significantly outperforming older models. The large score gaps and contrasting success rates underscore the advancements in social intelligence among leading models. These findings validate SAGE's effectiveness in quantitatively distinguishing these capabilities, fulfilling its role as a comprehensive assessment tool. Section Summary. In this section, we evaluate various large language models, LLMs, using the SAGE framework, revealing that while emotional response scores vary significantly across different sentient agents, their relative rankings remain stable, highlighting the importance of calibrating evaluations. Our findings also demonstrate that models with reasoning capabilities show enhanced emotional intelligence, and the SAGE benchmark effectively differentiates the social cognition performance of frontier models compared to older or smaller ones, underscoring the need for specialized assessment tools. Section: Token efficiency. In this section, we examine the token efficiency of the top 10 ARENA models by comparing their sentient emotion scores with their average token usage per dialogue. Our findings show that the best performing models on the Sentient benchmark also exhibit strong token efficiency, suggesting that effective social cognitive reasoning can be achieved without excessive wordiness. We notice significant differences in the amount of text generated by these models to produce supportive dialogues. For instance, GPT-4o latest achieves the highest sentient score of 79.9 while using only 3,300 tokens on average per dialogue. In contrast, models like O3 and Gemini 2.5 Flash Think use 13,300 and 9,000 tokens, respectively, but have lower sentient scores of 62.7 and 65.9. Additionally, GPT 4.5 Preview and DeepSeek v30324 have low token counts of 2,200 but do not reach the performance of GPT-4o latest, indicating that simply using fewer tokens does not ensure better social cognitive abilities. Our results indicate that higher sentient scores can be achieved with fewer tokens, reinforcing the idea that recent leading models are not only more empathetic but also more efficient in communication. The positive relationship between high sentient scores and lower token counts in models like GPT-4o latest and GPT-4.1 suggests that advancements in large language models, LLMs, allow for more effective and concise supportive interactions. Conversely, some models with similar or higher token counts achieve much lower sentient scores, showing less efficient language use. This observation supports the benchmark's assertion that SAGE can assess both the raw social cognition and the efficiency of LLMs in providing empathetic support, which is crucial for real-world applications where brevity is valued. In summary, our analyses confirm the usefulness of the Sentient benchmark for nuanced evaluations, distinguishing models based on the quality and efficiency of their social cognitive reasoning. The varied sentient scores and token usage demonstrate that SAGE enables researchers to evaluate not only the empathetic capabilities of LLMs but also how efficiently they achieve these results. This comprehensive approach highlights our main contributions, offering a specialized metric for higher-order social cognition and facilitating detailed comparisons across state-of-the-art models. To further differentiate the interaction styles of the evaluated models, we introduce a two-dimensional social cognition coordinate. The y-axis represents the focus of interaction, ranging from empathy-oriented at the top to solution-oriented at the bottom, while the x-axis captures the interaction style, from structured on the left to creative on the right. We plot the models in this coordinate space based on qualitative analyses of their dialogue patterns. We base our analysis on two key aspects. First, we collect 10 success and 10 failure cases for each model and prompt Gemini 2.5 Pro to summarize the reasons behind these outcomes, creating a profile for each model. Second, we develop a detailed strategy list for emotional support conversations and prompt DeepSeek v3 to analyze each response, annotating the strategies used. This allows us to obtain the distribution of strategy usage for each model. Using these analyses, we generate a conceptual two-dimensional coordinate system and determine specific coordinates for each model, averaging the results over 3 iterations. The social cognition coordinate system provides a qualitative dimension to evaluate the social interaction styles of LLMs, complementing the quantitative sentient score by positioning models based on their empathy versus solution orientation and structured versus creative interaction styles. This approach enriches our understanding of model capabilities beyond a single performance metric, mapping their engagement with users' emotional states and problems. Section Summary. In this section, we analyze the token efficiency of the top 10 ARENA models by comparing their sentient emotion scores with average token usage, revealing that models like GPT-4o latest achieve high empathetic performance with fewer tokens, while others consume more tokens with lower scores. We also introduce a social cognition coordinate to qualitatively assess interaction styles, mapping models based on their empathy versus solution orientation and structured versus creative approaches, providing a comprehensive evaluation of their social cognitive capabilities. Section. Several top-performing models cluster in the structured, empathy-oriented quadrant, indicating a common profile for effective supportive dialogue. In this section, we observe that several top-performing models cluster in the structured, empathy-oriented quadrant, indicating a shared profile for effective supportive dialogue. Models like GPT-4o latest, GPT-4.1, Gemini 2.5 Pro, GPT-4.5 Preview, and Gemini 2.5 Flash are primarily found in the top left quadrant. This suggests that they focus on listening, validating emotions, and showing empathy while also using a systematic approach to guide conversations. This combination aligns well with established supportive communication principles, balancing empathy with structured guidance. We also notice a distinct group of models that take a structured, solution-oriented approach, prioritizing task completion over deep empathetic engagement. Models such as O3, Gemini 2.0 Flash Think, O4 Mini, and Gemini 2.0 Flash are located in the bottom left quadrant. Their interactions are more methodical, focusing on identifying problems and proposing solutions. While effective for task-oriented scenarios, this style may seem less empathetic compared to those in the top left quadrant. The DeepSeek models occupy a unique space with creative, solution-oriented interactions. DeepSeek V30324 and DeepSeek R1 are in the bottom right quadrant, indicating a focus on providing solutions through more creative and unconventional methods. While they may offer novel perspectives, they might lack the predictability and structure seen in the left quadrants. Interestingly, the creative, empathy-oriented quadrant is largely empty, suggesting that current models struggle to achieve this profile. The top right quadrant, which represents a blend of high creativity and deep empathy, is not well represented among the models we evaluated. This indicates that developing a wise, unconventional mentor persona that balances creative interaction with empathetic understanding is an area for future growth. In summary, our analysis reveals distinct interaction profiles among state-of-the-art language models, moving beyond simple performance scores. We find that models with high empathy often balance structure, while others focus on solutions or adopt creative approaches. This framework helps differentiate models based on their interaction styles, providing deeper insights into their social cognitive abilities. For our case study, we highlight the differences in interaction styles among selected models. We choose 3 representative models: GPT-4o latest, empathy-oriented, structured interaction; O3, solution-oriented, structured interaction; and DeepSeek R1, solution-oriented, creative interaction. We also analyze Gemini 2.5 Pro, the top model on the ARENA leaderboard. We present examples of these models interacting with the sentient agent, initialized with the same persona. The GPT-4o latest model aligns with the persona of a personal counselor, showcasing strong empathy from a third-person perspective. Its responses are concise yet deep, uncovering hidden feelings and intentions, often enhanced with emojis for liveliness. The Gemini 2.5 Pro model fits the persona of a heart-to-heart friend, expressing emotional support in a more verbose manner. It employs various strategies like empathy, comfort, rhetorical questions, and praise, showing high emotional involvement and also using emojis. The DeepSeek R1 model embodies the persona of a creative actor. It uses creative analogies to express empathy in a fun way and offers personalized suggestions for actions and tasks that both the model and the sentient agent can work on together, emphasizing creativity through analogies and humor. Lastly, the O3 model represents a logical analyst. It focuses on analyzing the issues faced by the sentient agent and provides detailed, step-by-step suggestions. Its language style is logical and structured, resembling a markdown format for clarity. Section Summary. In this section, we analyze the interaction styles of various top-performing models, noting that those in the empathy-oriented quadrant, like GPT-4o latest and Gemini 2.5 Pro, excel in supportive dialogue by balancing emotional validation with structured guidance. We also highlight distinct profiles for solution-oriented models, such as O3 and DeepSeek R1, which prioritize task completion and creative problem-solving, respectively, while emphasizing the lack of models that effectively combine high creativity with deep empathy. Section: LLM as a judge and agent as a judge. In this section, we discuss the LLM as a judge and agent as a judge paradigms, which have shown impressive scalability and flexibility in various applications. We identify key uses of LLM as a judge, including 1. Model evaluations, where LLMs automate the assessment of generated outputs using methods like comparing pairs or detailed scoring. 2. Data annotation, where LLMs help label data for instruction tuning across different fields. And 3. Reward modeling, where LLMs create rewards to align preferences, validate reasoning, or improve reasoning performance during testing. In agent evaluation, LLM as a judge is used to assess various agent skills, such as decision-making, role-playing, reliability, and overall workflows. Additionally, agentic systems can act as a specific type of LLM as a judge. Current research includes developing multi-agent systems to improve judgment quality and the concept of agent as a judge, where agents evaluate each other. We propose the first sentient agent as a judge system, which assesses LLMs or agents using sentient agents that can mimic human emotional dynamics, allowing us to evaluate the advanced empathetic and cognitive abilities of existing LLM agents. Regarding benchmarking social cognition in LLMs and LLM agents, recent studies have focused on evaluating LLM's social cognition during interactions. This includes assessing emotional intelligence, improving empathetic skills in dialogues, and evaluating theory of mind. Existing evaluation methods involve using static datasets for social cognition assessments, evaluating single-turn generation quality, or simulating dynamic interactions between LLM agents and judging their behaviors through automated or human evaluations. We introduce a sentient agent as a judge framework to evaluate LLM agents' higher-order social cognition. The key difference in our approach is that, while we enable dynamic evaluations through simulated interactions, we focus on providing human-like authentic feedback based on users' emotional changes and thoughts, achieved through the thoughtful reasoning of the sentient agent. Our framework is also adaptable to various evaluation scenarios for assessing LLM agents' higher-order social cognition.